Okay, I think we are up and running. Looks like the microphone is working. Our connection is good. Good evening, everybody, from the deserts of Eastern California here in the Death Valley region. Good evening to you, and Happy New Year to all of you who are listening, whether you're listening live or later on. I hope you had a great New Year. Hope you've had a great holiday season. I know I have. And, well, tonight we got one last night before the moon gets too bright to really have a lot of fun. And so, thought I'd do one more live stream tonight. And, yeah, so we're going to look at just kind of some of the best of stuff. Sort of the best of what's in the sky right now. Sort of the best and the brightest of what's up there. I mean, we looked at a few pretty cool things the other night with the observing challenge, the Cloudy Nights Observing Challenge that we did. But there's a lot more really cool stuff, and so we're gonna start taking a look at some of that stuff tonight. And one of the things actually, we were a couple minutes early, but one of the things actually I like looking at is let's see, where are we here? Yeah, let's go to the Triangulum galaxy, is one of my favorites. So it's a good one to start off with. And we'll go right up there. And it's kind of not really at the meridian yet, so hopefully we won't get too many. That's a little high, but hopefully we won't get too many satellites from it this early on. Okay, let me turn off the little test pattern we got there, and so we're going to try and go to Triangulum to start off with. Send the scope over there. Okay, yeah, that looks all good. All right, and we'll plate solve it. Actually, I think it's right there. So I think maybe you are sending me off to some crazy other place again. So I'm going to re-slew, because I think you were pretty much right on the first time. Sometimes the software does betray you. Yeah, I can see the core of it right there. So let's do that. And I think I'm on. I think I've got everything I need to go here. Hello, you're not responding. Okay, yeah, we're on 1 minute, 53 gain. The gain is correct. I got the flats loaded, the darks loaded. Okay, well, I think we should actually get somewhat of a. I'm not sure why we have a histogram here. I guess I will clear that. And let's get this out of the way. And see what we come up with for our first image. In fact, I think I will get you out of the way as well. It is a little bit breezier than they were forecasting tonight so far. I'm hoping it will die off. I think it's already kind of dying off a little bit. But we do have a little bit of breeze going on, so things might get a little blowy. You might hear the breeze in the microphone. But that's just how we might have to roll tonight. But hopefully not for very long. Okay, Triangulum Galaxy. Triangulum Galaxy is one of our local galaxies. It's one of the local group. It's one of our neighbors. It's actually the second nearest to us. I believe it's 2.3 billion light years away. Andromeda is, of course, the closest, and that is only 2.5 or 2.25. So this is the Triangulum Galaxy, and it's really nice to image, and it's because it's so close, and it's just a very pretty one. It's so close and so bright and so large that It's a really good one to get. Howdy, Daryl. How's the weather in Texas tonight? Alright, I think we're doing good there. That's a decent start. Let me get Wikipedia going and say M33, which is going to be our... that's not what I... Okay, no, you have to actually type out Messier. Messier 33 Triangulum Galaxy. There we go. It's a spiral galaxy 2¾ million light years away in the constellation Triangulum. It's called Messier 33 because it's the 33rd object in Charles Messier's list of objects that were not comets. Because they weren't comets, he wasn't interested in them, so he wanted to know all the things he could ignore in looking for all of his comets. See, it is about 61,000 light years across, which means it's about half the size of the Milky Way. It is the third largest member of our local group, behind Andromeda and us. Galaxy is the second smallest spiral galaxy in the local group, after the Large Magellanic Cloud, which is a Magellanic-type spiral galaxy. It is believed to be a satellite of the Andromeda galaxy, or on its rebound into the latter due to their interactions, velocities, and proximity to one another in the night sky. So it is actually believed to be a satellite of Andromeda, which is kind of cool, because they are fairly close to each other and to us, so I think they consider any galaxy that's within a couple million light years of each other as interacting. Just gonna need to make sure we don't hit this line here. There's the Andromeda galaxy. It's already gone over the other side. I don't... It's actually way too big. It's so close and so large that it's way too big for my field of view. So, with a different setup, with my old scope, I could get it a little bit better. But with this scope, it's just a little bit too large. I have to get it in pieces, basically at least 2 or 3 pieces to be able to get the whole thing. Alright, let's start the background music here. Got that going. And we'll keep going on this guy. Let's adjust our colors. Yeah, was looking a little weak in the blue. Let's take that. Dave, not sure who Mark is, but I think you might be thinking of somebody else. Texas is cloudy, Daryl. Ollie, oh my gosh, Ollie, you're here. Boy, it must be really early for you. Holy moly, it must be like 2 a.m. or something at your time right now. But thanks for showing up. I do appreciate it. I know how early you have to do to get up for our winter broadcasts. It's funny, you know, our winter broadcasts are early enough that the East Coast can get on in time to see them. But now they're just way too early for you Euros. But our West Coast our summer broadcasts are just the opposite. We can only start at 9:30 or 10 p.m. Our Eastern Seaboard can't, you know, it's way too late for them to be up. So, you know, my parents and friends and things on the East Coast like watching these, and so it's way too late for them. But with that late a start, it's only, you know, it's like 7 a.m. for you when we get started here. So it's just a lot nicer. So really appreciate you being here, Ollie. I don't know if that's good morning or good night at 3 a.m. That's kind of like middle ground. Do you stay up for that, or do you wake up early for 3 a.m.? I don't know. Thanks either way. Oh, and you know, Ollie, I wanted to tell you that I actually bought a 676. I saw the threads you posted about it and bought a 676 camera and tried it a couple of times, and back to back with the 183 a couple of different nights, about 6 hours of imaging I did on 2 different nights with it, and it was a nice little camera, but it just, the more limited full well, it just made the colors a lot more muted for whatever reason. I could get things just as bright, but the color reproduction just wasn't good for what wasn't as good as the 183 for whatever reason. It was nice not having to go with the with darks and flats, but it just I tried it for a couple of long sessions, and it just I couldn't get this kind of color reproduction. And obviously the sensor is smaller too, but finer pixels. But I couldn't get this kind of color reproduction, and even with the finer pixels, I didn't really notice any resolution improvement. So I've still got the 676. I may play with it once or twice more, but I went back to the 183 because I just couldn't beat the images that I was getting with the 183. So I wanted to let you know I did give it a try, and I may still try it once or twice more, but yeah, it didn't quite work out as well as the 183 for some reason. Even though the 183 requires more maintenance, more calibration files, you got to have your darks and flats because it's an older sensor technology, so it does require its maintenance. And but it just, for some reason, with my setup, it just seems to work better with the 183. I was kind of surprised by that, but I don't know. It was just did give it a good try though. I may yet find a use for it. I just haven't. So far, doing this big, bright, shiny stuff, it works out just a whole lot better to use the 183. And I like the bigger sensor, obviously. Bigger sensor is nicer. But the 676 is a good camera. It totally is. But I just back to back with the 183. I was hoping it was going to be at least as good, if not better, than the 183, and it didn't turn out that way. So, what are you going to do? Yeah, for me, it definitely works. It works better. I don't notice like I said, I didn't notice a big resolution difference between the two that was of any significance, and I just got better colors, and seemed to be more dynamic range. I seem to have be able to pick out more details and things. Different from resolution, just more color levels. Even though on paper they don't seem to have, they seem to have about the same dynamic range. I think the 183 may have one step more, but I don't know. Anyway, I did give it a try, and I appreciate that you sent it to me. You recommended it because it seems like a good little camera, but I ended up going back to the good old 183, and have really been enjoying it. So. If I do get into planetary at some point, it would be a good choice. Maybe the moon. Moon would be fun to do with it. I may try that. I don't do solar system stuff. I like doing extra galactic stuff. Well, not even that. I just like doing DSO, which of course includes a lot of stuff that's in our galaxy, but then there's a lot of stuff like this that's outside of it that I really like doing. And so I don't have much call for a planetary type camera typically. Although I guess the 183 technically is considered a planetary camera. So, thanks, Dave. appreciate the compliment. Our Triangulum galaxy. One of our closer neighbors. Looks like the colors have gotten a little out of balance here. So, get those colors back in. I'll probably keep my mic muted a bit more tonight until the wind drops down, because I know it creates a bunch of wind noise on the mic, so I'll try and keep myself muted as long as the breeze stays up. Alright, there's 15 minutes on that. Ha! Satellite tried to get us at the last minute. Whatever. Well, you know, one of the things I've been enjoying doing, now that I got this new setup, no, not that one, is reflection nebulae. And let's look at what's up tonight, and bright nebulae. And, of course, the Pleiades, which is... the Pleiades? Yeah, the Pleiades is up there pretty well. Let's see where the iris is. Let's see where the iris is. It's on the other side. Okay. I like iris. Iris is a good one. Cave. I suppose we could flip over and do that. Yeah, there's the cave. Wizard. Iris is one of the ones I've liked doing. So let's go to the iris. I want to do the iris next. Okay, so we'll say good night to Triangulum galaxy. We'll head over to the Iris Nebula. Which means we're going to flip over the meridian. Target. We'll go in here. Actually, I think that's it. Yeah, I think that's it. So once again, we're going to get dragged way off. I don't know why Stellarium does that. It says we're... It's really kind of weird. Anyway. But the second slew always gets me right on. Yeah, there it is right there. It was pretty close, but for some reason, Stellarium thinks it's much further away than it is. Okay. That's the Iris Nebula. Also known as NGC 7023. It's a bright reflection nebula in the constellation Cepheus. The designation NGC 7023 refers to the open cluster of stars within the larger reflection nebula, designated LBN 497. And it has an LBN designation because it's also a dark nebula. So, well, that would be LDN actually, bright nebula, and LDN dark nebula. But this is actually a mixture of both. It has the bright blue reflection nebula, and it also has the dark nebula as well, which we will be able to see once we resolve it for a bit. Alright, first sub, yeah. This is the problem with doing something in the western part of the sky shortly after sunset. I forgot about this. Get things at least color balanced and whatnot. And I will clear this sub, and we will wait for the next one, but you can kind of see what I'm talking about here with the dark nebula spots and the bright nebula spots. It's a mixture of the two. Alright, bye-bye satellite. The nebula, which shines at a magnitude of 6.8, is illuminated by the magnitude 7.4 star. It's located near the mirror-type variable star T Cephei and near the right magnitude variable star Beta Cephei. It's about 1,300 light-years away and is 6 light-years across. So, I'm assuming they just measure this part, because the reflectivity does go actually out a ways. And as we resolve more subs on here, you'll be able to see more of them. But this is one of my favorites. I know I say that about a lot of things, but this one is really works really well with my new setup. I guess I can say that. It really makes my new setup really makes this one makes reflection nebulae pop, so it's really a good one. So it's about 1,300 light years away. Hi, Michael. Thanks for coming in. Happy New Year to you as well. Dave, let me know if my volume got better just now. I'm hoping it's not the wind noise that's causing it to deaden my voice. With this microphone, I need to keep it very close to my mouth, or it does get too soft. So let me know if my volume is better now. Okay, good. Yeah, this microphone, I just moved the mic a little closer to my mouth. This mic is really super sensitive. I think it's a noise canceling, and so if I get it too far away from my mouth, it thinks part of my vocal signal is noise, and I think it attenuates my own voice. So I just have to keep it really close to my mouth, and then it works a lot better. My new setup, hey, you know, that's a really good idea. While this is building, I should go, let me go look at... Let me go get, the new setup I just took a picture of tonight, and so I need to bring that over here onto my desktop and put it on the desktop here, and there we go, and this, well anyway, I should clean those out. And let's bring this over here so you guys can actually see it. I can't grab it. Gotta grab the little arrows. Okay, now you guys can probably see this. So this is my new setup. Same AM5 mount, slewing it around the sky. Same spare no expense cinder block pier that we all know and love. And this is a new scope. This is a C8, a Schmidt-Cassegrain, Celestron Schmidt-Cassegrain 8-inch telescope. And on the front here you can see the Hyperstar mounted. And now that I'm out here and I have it set up, I have the camera right on the front there. And so, yeah, so that's the new scope. Everything else remained the same, but this is the new scope. And I've got the table set up back here, and I'm sitting right behind the scope as we speak, controlling everything and talking to you. So I just took this a couple hours ago when it was still somewhat light, so you can see what it is that I'm using. But this is the new scope. And then Ollie asks, why did I switch to the new scope? Well, just as a trial. One happened to come up for sale in the used market for a decent price, and it was a fairly newer one. It was it's a scope off an SE8, so it's a fairly new-ish SCT, not one of the old orange tubes. And I wanted to try it. With the Newt, I started off at f4. That worked really well. And then I got the Nexus coma corrector reducer for it, and that brought me down to f3, and boy, that made everything just even better. And so it seemed like the faster I went, the better things got. And so I just figured, okay, how do I go faster for a reasonable amount of money? And the best way to do that is to go with a Hyperstar on a Celestron Cat. And so I bought this to try out, and then I just waited for version 4 Hyperstar to show up on the used market. The thing is mounted on the front here. I wanted the version 4 because it was the fastest and widest field of view, widest image circle on it. And so it took a few weeks for that to show up, but eventually it did show up, and I was able to snag that and then put them together. And so I've been using this new setup for a couple of weeks now, and sure enough, the faster I go, the better. I could see 75 or 80% of this galaxy at f3 with 3-minute exposures, but now at f1.9 I'm doing 60-second exposures and getting even more of it with 1/3 the time. So yeah, I'm just totally addicted to speed, focal ratio wise, and you know, it worked out great. So why did I go with the SCT? As an experiment. I bought everything on the used market. I tried it out. If it didn't work, I would have just sold it back for very little money lost. So I like doing this now and again. I buy stuff on the used market to try it out. In worst case, it doesn't work. Then I throw it back for about the same amount of money, and I don't lose very much money to try stuff. And so I'm always playing beat the control, where what I've got is great. Let's see if I can do something that does even better. And so in this case, it was a complete success. This is just really working out well for me, and yeah, having a great time with it. So hopefully that answers your question, Ollie. I really have enjoyed it a lot. It's working very well for me. And unlike the Newt, the SCT is the Swiss Army knife of telescopes. With the Newt, especially an imaging Newt, you're fairly limited to what you can do. They're really designed to be fast and to image things. But this, you can be anywhere from f1.9 with the Hyperstar on the back, or you can use the back of the scope on the front, excuse me, or you can use the back of the scope, and you can use it at f10, 2000 millimeters. You can use it at f6.3 with a 6.3 reducer, at 1300 millimeters. You can use it at f3.3 if you get one of those reducers. You can use it at f20 if you use a Bortle. So it can be used at a lot of different focal lengths and do a lot of different things. And so it's a much more universal, usable scope for all kinds of different things. And so it's just more flexible. So it not only does what the Newt did, but even better, but it's also a lot more flexible to do other things. So I'm looking forward to exploring all the stuff it can do, and over time I think I will, you know, have a lot of fun with it. It's certainly with the Hyperstar, it's been great. So I can't complain about that at all. Mike says, sweet, must be very fast, f2. Yeah, it's actually f1.9. The V4 Hyperstar is f1.9. So, yeah, I get to say I'm faster than f2. Haha. Are those vibration... Oh, the vibration absorbing bricks. Yes, these are the special Celestron vibration absorbing bricks with the vibration absorbing construction adhesive between them. So, no vibes, just all good stuff. A nice Christmas present, Michael says. Yes, it was a great Christmas present to myself. Typically, my folks send me a check anyway because they know I know what I like more than they do, and so it kind of sort of paid for this, and so yeah, it was. But as it turns out, I'm just selling my Newt stuff off now, and I've already sold the Nexus. I've already sold the Paracore. I'm selling all that stuff off because this just works so much better that I probably won't even be using the Newt anymore. I'd sell that if it was worth selling, but the shipping would cost 50% the price of the scope, so it's kind of not really worth it to box it up and send it somewhere. But anyway, yeah, it really is. It really is, Ollie. It really does. It really is seeming to be perfect for me. I don't know. The dark skies, of course, help with a lot of things, but in this case, it seems to also really help with a lot of speed. My dark skies really, the faster I go, the more benefit I get from the speed, I guess, or the more I realize the benefit of speed. I'm going to unstack this because we got a satellite that went right through there, so I'm going to take that last sub out. Get rid of that satellite trail. Doink, gone. I love that unstack button. Thank you so much, Robin, for adding it. Finally, after many years of requests, finally adding that button. It's so nice to just be able to back the last satellite-infested sub out of the image and not have your whole stack ruined. Yeah, I guess we all benefit. Yep, it definitely has some really nice images, and in this now we can really start to see. Obviously, the reflection nebula is very obvious here, but the dark nebula that's all around it, where it's sort of this brownish color, and then goes right to a dark nebulosity. So these are all areas of dark nebula, and the blue is a reflection nebula. And we'll see some other nebulosity tonight that's going to be red in color, and that is emission nebula. It's the red is typically hydrogen, and the blue is typically oxygen. But in this case, it's just full spectrum reflecting that one bright star that's right there in the cluster. L asks, do you find at F2 that you have to reduce gain and exposure time to prevent blowing out bright out? Oh, of course, yes. Yeah, the faster you go, or the longer the exposure, or the higher the gain, the more you're going to blow out bright stuff. So yes, in this case, with the Newt, when I was at F3, I was doing 3-minute sub-exposures to get this kind of brightness, and actually it wasn't even quite this bright. And with this, I'm, and obviously you have to use guiding when you're taking exposures of that length. In this case, I'm at 60 seconds, I'm getting more than I got with it at F3 before, and so I'm not even having to use guiding. You'll notice on this picture, there's no hardware attached to this. There's no guide scope, no nothing on here. It's just the scope. And so I don't even need to do any guiding with it. So yes, I'm keeping my sub-exposures real short. When I do really bright things like star clusters, I'm doing only 15-second subs, and sometimes even cutting that back. Yeah, so you do have to cut things back. Even this, we could get this core really much more blown out than it is. But in fact, we could even. Whoops! Whoops! What am I doing? Wrong. Clicked the wrong button. I wanted to just zoom in here. We can see a little bit more detail that's going on in that Iris Nebula. I'll have to wait until it I'm monitoring my own broadcast, but there's about a 30-second delay between what I do and what I see, so I have to kind of wait and see what you guys see before I make any adjustments. That's probably about right. But you can see there's a lot of cloudy nebulosity going on in there. That's pretty cool. And if I wanted to reduce the stretch a bit, as L pointed out, I could reduce the stretch a bit, and we'd lose some of the fainter nebulosity, but we'd see a bit more of the core, a bit more of the star cluster that's actually in here. That's illuminating this whole thing and making it reflect from its starlight. So it also adds a little bit more texture to the detail. In fact, we can even wrong button again. Okay, going a little bit further. It gets a little grainy when we start getting this close in, but you can kind of see there's more. Just a lot of the cloudiness is in there. And that's the beauty of the 183, nice small pixels. The 676 has even smaller pixels, but for some reason I didn't notice all that much increase in resolution, so oh, elephant's trunk. Yeah, we can do that. Try the Hyperstar instead of the Night Owl. Yeah, well, the elusive vaporware Night Owl. They've been promising the new Night Owl for how long now, and have never come out with it. But hey, hi Tiffany. Yes, hit that like button, hit that thumbs up. Then thank you very much. Good you're here. Yeah, no, I know what you mean. Elephant's trunk. Yeah, I think it is 1396. But yeah, I know what you're talking about, and yeah, we can do that in a bit. Again, it's way too big to get the whole thing in, but we can at least do the trunk part. So, yeah. I wonder if we can actually reduce the stretch even more. Get a little more of the core of the... Yeah, I think now we're starting to resolve the one individual star. I'll have to see how that looks for you guys. That may be too dim, but still see a little more of those. It's like some light rays coming off there. Starts to get a little grainy when we get in too close, though. It's just a very cool nebula. I really like looking at it, and it works very well with my setup, and the fact that because I'm in such a low light pollution area, I don't need to use filters. The only thing I am using on this is a UV-IR cut, and that allows a lot of the light through. So unlike folks who are stuck in light polluted areas, which is most people, having to use filters to cut all that noise out, I can pretty much let it all through. So that's a pretty big advantage. It's a pretty big advantage that I've got. Oh, look at you, you son of a... You know what? I'm going to leave you. You're outside, but what the interesting parts anyway, so I'll just leave you. But yeah, you can really see the contrast between the light parts and the dark parts, and what looks like sort of a hole, a hole right through the nebula, where the nebula isn't covering up the background stars. Sort of a keyhole right through there. L says, I use an 8-inch f4 newt for EAA. Yep, struggled with the Nexus. Oh, really? I really loved my Nexus. I had a great results with it. I did have a custom mirror cell on mine, though, where I had the mirror drop back about 1 inch so that I could bring everything. I could bring the focuser a lot closer to the scope. That did make some things easier. But I really enjoyed using the Nexus. I also have the Skywatcher, the Aplanatic 1.0 coma corrector. I used that for a long time. It works really well. That's what I used until I got the Nexus, and then just fell in love with F3, so I kept using it. So, yeah. Well, you want to go for the Edge? You can go for that. Edge is more expensive than a regular one. And unless you're using, well, it depends on what you're using the scope for, whether you should get an Edge or not, or just the less expensive regular one. With the less expensive regular one, things are cheaper. Things like reducers are a lot more available, etc. But well, anyway, we've been on this for a long time. Let's go look for. Yeah, so Ollie wants to go over here. Ollie wants to go over to the elephant's trunk. Well, let's see what we can see here. So if I center my view there and then get my... Yeah, see where... I'm obviously not going to get very much, but we'll get the exciting parts, I think. Yeah, see, so the actual elephant trunky trunk part is up here. Let's see if I can do... Yeah, maybe that'll work. That'll get a lot of the more interesting stuff, I think. Too low. Hit more of the trunk itself. Okay, let's try that. Alright. Good night, Iris Nebula. You are such a beauty. Let's go to the trunk. Nice short slew. And let's plate solve on that to make sure we are where we say we are here. Okay, very good. And now let's plate solve to make sure we're on target. Yep. Good. Okay. Okay. Let's see, Michael says I use the Nexus now with my heavily modded 18-inch job. Yeah, I really like the Nexus. It works a treat for me. Yeah, back focus. Back focus is an issue. With the imaging newts that we have, most imaging newts, the 6 and 8-inch and 10-inch imaging newts that we have, they usually they design them so that as an entry-level imaging scope, and so they assume people are going to use, when they first start imaging, what they have on hand, which for most people is a DSLR or some other bodied kind of camera. And so they actually make it so that, and because a DSLR, the sensor is way back in the back of the camera, they have to put the focal plane of the scope out quite a ways from the edge of the scope, such that the focuser, when you adjust a DSLR, it's going in close to the scope, but you can have enough back focus to get the sensor way at the back of the camera body to actually focus. And the problem is, for those of us who use astronomy imaging cameras, for which the sensor is at the front of the camera, you end up having to have the focuser extended way out to bring it to focus. So for most of us who use the astronomy cameras, that becomes a little bit of an issue. The longer the focuser is, the more sag there is in it, and then you've got tilt in your images, and because the sensor is not perfectly square to the focal plane, and blah blah blah. So it becomes a bit of a challenge. So what some of us end up doing is either going with a custom mirror cell, building our own, whatever, moving the focuser itself in the scope, such that you essentially lengthen the focal length a little bit, so that the focuser can go in closer to the scope. And that's what I ended up doing with mine. But back focus, when you're changing objects like that, is changing optical elements, like reducers especially. They like to they often demand something with more back focus. Trunk is NK. Trunk, yes. And so, you mod it however you want to. But in this case, with the SC8 and the Hyperstar, you don't need to do that, because it's just it just makes it f1.9 or f2 whatever, without having to monkey with any of that stuff. It dramatically shortens your focal length without having to monkey with anything custom. You don't have to hack it. And so it just works a treat. I love it. Mainly because the Nexus is so long that it cuts into the light path. Unless I pull it out a bit, then the focus point moves further out. Yeah, because I had a custom mirror cell, I was able to move my mirror forward or backward, so that the camera was close into the scope, but not so much that the end of the Nexus poked into the light path. And that is a tricky bit. But that was the nice thing about having the custom mirror cell, is that I had a lot of latitude about where I put the primary mirror. So I had a lot of adjustment there. Shark teeth protrusions. They could be. Over time, they do smooth out. So I'm not sure. It's a good question. I don't really know myself. I think I'm going to pick up the red a little bit on this, because this is it's a hydrogen-rich deal. So we'll cheat and pick up the red a little bit. There's the elephant's trunk there, although I don't know why it's the elephant's trunk, but it's a very interesting emission nebula. It's better with narrowband emission filters. I do have an NBZ that I'll be using on the scope here. Now the moon's going to get brighter and brighter. I'll probably do some narrowband imaging with the NBZ, and that will really bring this out more. It'll cut the stars back a lot, bring out the red hydrogen, make it pop out a bit better. So this isn't an ideal target to do broadband, but it's still a pretty interesting target. Again, a nice mixture of emission nebulae and dark. So lots of zones of dark nebulae and even some Bok globules, which are basically dark spots of protostar material that are in this. So it's a pretty cool object. And it's a lot bigger, obviously, than my current field of view. So I usually shoot this with my my Canon 200mm camera lens, because then I get like a 4 degree by 3 degree field of view, and this fits well within that. It fits in there pretty nicely. Let's see. Let's just... Ooh, satellite. Boy, until I stretched that, I didn't even see that satellite. Let's just unstack. I assume that's in the last stack, hopefully. Hopefully, we'll see. Yep, yay. It wasn't the last one. Thankfully, the wind is easing up. Still got to keep my mic muted, though. In fact, while this is stacking, I'm going to go in for a minute and get me a warm beverage. I'll be back in just a minute. Okay. In fact, that beverage is so warm, it's going to have to cool for a minute. All right. Try cranking that. Try cranking that histogram. Cranking that stretch. Seems like the wind has changed direction and coming out of the north now. Thanks, CND boy. You Happy New Year as well. Thanks for being here. Appreciate you stopping in for a look-see. We're looking at the Elephant's Trunk Nebula right now, or at least part of it. Alright, well, since we're over here, what should we look at? Let's see, we could do Pelican and part of North American. Take one quick peek at that, but it's a little lower in the sky, so we already did the iris. Yeah, we were just there. Wolf's Cave. Yeah, it's a pretty dim one. I think we'll do that. Regular cave nebula. The Wizard. Well, I guess we can go do North American real quick. This might still be a little bit too low. And again, we can only see, you can see why it's called North American. It looks like North America, but we can't quite see all of it. My field of view is a little small, but we can try and get a good chunk of it anyway. Oh, thanks for the sub, CND. Really appreciate it. Alright. We'll go take a quick look at North American. It's just a short hop away. And we'll just go because we're pretty close to it. So we'll just go on it. Holly wants to see NGC 660 next. Okay, well, NGC 660. Where are we? Well, we're very close to. It's very close to the meridian. Yeah, so what I may do is we'll do 660 in a bit. Oh, I'm sorry. No, it's crossed the meridian. It's on the west side of the meridian. We're on the west side, right? Yeah, okay, we can do that next. NGC 660, we'll do that next. How are you capturing flats? Are you doing sky flats? No, I have a flat panel. For the 6-inch imaging newt, way back when I bought a flats panel for it. And so that's how I've been doing my flats for quite a long time with the newt. And luckily, I got the 10-inch because it actually fits over the dew shield I made with the for the SCT. So as you can see here, I've got it reflectix wrapped. I wrap the OTA with Reflectix, which helps keep the internal temperatures more stable, so you don't get air currents in the scope as it cools down. And so I wrapped this. I had to go buy a whole roll of it, so I bought a 10-foot by 2-foot roll, which is the smallest roll you can buy at the big box hardware stores. So I have a ton of it left over. So I basically have made a light shroud for the front. It's not a dew shield for me since I don't have dew, but I do have stray light from neighbors and things. And so I made a light shield out of the same material. Since I have a whole bunch on hand, I could make a whole bunch of them. And so I made a light shroud, light shield over the front here. And so when I'm ready to take flats, I just point the scope at or near the horizon, basically near the meridian, about plus 30 degrees declination. And I just put the panel right on top of it, and I take my flats that way. So I just make it so that the opening on the light shroud is level enough that it will hold the light panel without falling off, and I just quickly take the flats using SharpCap. So, and then I took these flats, the flats that I'm using, I took I think on the 27th of December. And since I don't change anything in the optical train, the only thing I do is take the camera off the Hyperstar and just cap everything, and then put it in this plastic box, the scope, with the Hyperstar left on it. And then when I come out and set up, I just screw the 183 back on right where it was before. I don't really need nothing of significant changes in the optical train. So, oops, we did get a satellite through here, huh? Nothing of significance changes on the optical train, so I can just use the same flats over and over again. So that's what I end up doing, is using the same flats for quite a while. In fact, I'll probably, until I change over to the NBZ when the moon, over this next week when the moon is out, I'll probably change to the NBZ, take the UVIR cut filter out, put the NBZ filter in, and then I will change, take a new flat. But not before then. So, yeah, I just basically point it straight up, or as straight up as I can get it, and put it on there. Yeah, with the camera on the front, it just make a light shroud out of whatever material you want. They do sell, nice aluminum dew shield / light shrouds for these scopes, but they're like $140, and so I'm just a cheap-ass DIY guy. So when I have a 10-foot roll, basically 8 feet of Reflectix left, it does just fine to make a light shroud out of. So that's what I did. Okay, you know what? Let's kind of back off on this a little bit. I think we're clipping the blacks a little too much. We got a kind of a spread here for the histogram. But yeah, you can kind of see the top of the New England. We're mirrored here, so there's New England, there's the Great Lakes, the whole upper Midwest here. So that's the portion of the North American nebula we're looking at. Another interesting object, but for some reason, normally this is a nice, like, peachish color. The whole thing is a nice peach color. And for some reason, with this scope and the Hyperstar, it doesn't come out that way. Not really sure why, but it doesn't. So, try kicking up the red a bit. That will probably help. But, yeah, it doesn't. It seems much more detailed and uneven and more textured with the nebulosity. So I don't know. This setup seems to do it different for whatever reason. Not sure why. Yeah, that's about right. That's about good. Boy, this histogram is doing weird things. A double peak That's pretty interesting. Where are we pointed here? Yeah, we're up over there. The Cygnus is starting to get low now. It's January. Starting to get lower in the sky. So Cygnus over here, we're over here. Starting to get lower in the sky now. Earlier and earlier. Losing all of our summer stuff. Thanks, Tiffany. And we'll take this one last sub, and then we'll head over and do Ollie's Galaxy in GC 660. It's just past the meridian, so it's in a good space. Alright, North American. One of the last times this year we'll be able to see you. Maybe the last. Start headed under for the winter. Alright. Go check on that. Okay. Get you in there, and now we will plate all of you to make sure you're in the middle. And then we'll start our... Oh yeah, there it is there. Just going to bring it up into the middle. And get going. Okay, so reset this, and GC 660. And GC 660. Polar Ring Galaxy. This is a pretty warped peculiar. It's a peculiar and unique polar ring galaxy located 45 million light-years from Earth in the constellation Pisces. It's the only such galaxy having as its host a late-type lenticular galaxy. It was probably formed when two galaxies collided 1 billion years ago. That's what it looks like to me. It's very warped looking. However, it may have first started as a disk that captured matter from a passing galaxy. This material could have over time become strung out to form a rotating ring. Well, let's see what we can see here. Oh boy, I can already see there's more than one galaxy in this picture. I can already see we got a couple in here. So there's the one we're looking at. There's one there. There's another one there. Interesting. And it looks like the mount hadn't quite settled when I started this, so I probably will delete this sub. Because we've obviously got some streaky stars going on here. But a very interesting, warped-looking galaxy. Alright, let's do a do-over here. Hopefully we'll get some round stars on the second sub. That's a lot better. which means we'll also get a lot better detail. You can already see a dark lane in here, some of the material. Interesting choice, Ollie. Thank you for this. We'll definitely look at all three of these. Oh, looks like another one up here. Okay, it's blah, 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 blah. The ring is not actually polar, but rather has an inclination from the plane of the host disk of approximately 45 degrees. The ring is 50,000 light years across, much broader than the disk itself. It has a greater amount of gas and star formation than the host disk. This likely indicates a very violent origin. Polar ring, okay. Interesting. Well, as we get, yeah, you can see the start of the polar ring here. Well, actually, I think this might be the ring of origin with this, the spiral galaxy, and this is the polar ring of the colliding galaxy. Not sure. Oh, it's a late-type lenticular. Okay. So, this is a lenticular galaxy, which means it probably didn't have much of a dust lane. And then the galaxy that collided with it kind of turned it on its side. Well, once we have gotten a few more subs, we'll zoom in a bit more. But you can probably already see there's definitely a crisscross. There's two dust lanes, one going this way and one going this way. And so they're there's one of the rings is polar, so that's how they mean by polar ring. Very interesting target, Ollie. I don't know that I've ever seen this one before. You see 660. I'll have to remember this one. Boy, you'd think you do this for a few years and you've seen everything. There is just so much out here. Elle says, if you have time, I would be curious to see how fast your setup captures the reflection nebulosity in M45. I realize we'll get oh, yeah. Well, the answer is very fast. And we will definitely do that. In fact, we could even do that next. It's climbing up to a nice height behind me here, so we can even do that next. Although I'm on the wrong side of the meridian for it, but we will definitely do M45 in a bit. It is one of the highlights. It's much closer and therefore bigger and brighter than the Iris, but it's along the same lines. And it is, and this setup does a really spectacular job of it, so yeah, we'll get to that in a bit. Stay tuned. See, it is here on the other side of the meridian, so let's figure out if there's anything else on this side we want to see before we poke over. I guess we could take a quick look at Andromeda. It's, like I said, it's too big for my view, but it is pretty spectacular. It's too big for my field of view, but and M74. This really isn't a galaxy setup, and I say that ironically because I started off in the Triangulum galaxy. Unless they're pretty big and bright, this isn't the ideal setup for it. Probably putting the 6.3 reducer on and getting the Hyperstar off and going for a longer focal length would be better for that. I may end up doing that for galaxy season, looking at using the 1300 millimeters to go for all the galaxies. I don't know, we'll see. I'm just having so much fun with the Hyperstar, it's hard to think about slowing myself down to f6. That's just a massive slowdown. So, because the actually, yeah, that's like more than 10 times slower. because the actual speed is the square of the focal ratio. So at f1.9, that number is 3.6. The square of f6 is 36. And this is like over f6, it's like f6.3, 6.4, depending on how much backspacing I use. So it's more than 10 times slower collecting light at f6.3. So the Hyperstar just spoils you. We'll take a look at these two guys together and zoom in a bit more. You guys can see some more of that. Goes to crisscrossing dust lanes, the polar dust lane, and this one's just kind of warped around. Let's make sure our color balance is doing okay. Yes, it is. Gets a little grainy when we get in here this close. But I think for this detail it's kind of worth it. And one thing I can do is turn on a little color noise reduction. Yeah, that will help. Although maybe not quite so strong. But a little color noise reduction will help. See, I'm waiting to see if it, yeah, it helps. For the big zoom-ins, it helps. But just a very interesting galaxy. You got the disk in here, and then its dust lane, and then some lenticular came in and tore the whole thing apart. Now there's two dust lanes crisscrossing each other. That's pretty darn cool. Let's see what else. The ring is not actually polar, but rather has an inclination from the plane of the host disk for approximately 45 degrees. Yeah, so it's not a perfect cross. It's not going this way and this way. It's about 45-degree angle between the two. But still, they still call it a polar ring galaxy anyway. The extreme number of pinkish star-forming areas that occur along the galaxy's ring could be the result of the gravitational interaction that's caused by the collision of the two galaxies. The ring is 50,000 years across, much broader than the disk itself, and has a greater amount of gas and star forming than the disk. Dark matter halo. In late 2012, the Polar Ring Galaxy produced an enormous outburst having a magnitude of approximately 10 times brighter than a supernova. Cause is not certain, but this event may have resulted from a tremendous jet being emanated from the galaxy's central black hole. Interesting. Definitely an interesting target, something to come back at when I've got the 6.3 reducer on the back and I have a lot more focal length. Be able to zoom in a lot more, and without it being so grainy. Actually, this looks like another galaxy here. Let's pull up our annotation and see what it has to say. Yep, it's a PGC. On there. Yeah, a little PGC galaxy in there. Well, that's a very cool galaxy, Ollie. Thank you for mentioning it. Let's see, M74. Yeah, I said we go to try Andromeda next. Since we're on this side, it is a very big, bright deal. Yeah, we'll get we'll get the highlights. It'll certainly be a lot bigger and brighter than this, but not nearly as interesting. This is very cool. It's very cool. I like what I likey. It of course needs more time, but to get it less grainy. But you can see this. So this ring here is about 50,000 light years, which is bigger than the disk. Somehow all this stuff got pulled out away from the main disk itself and turned into a polar ring at 45-degree angle to the angle of the spiral itself, the disk of the galaxy itself. So, interesting stuff. Thank you, Ollie, for that suggestion. That was very cool. Let's go and move on to Andromeda. There she is, and there's 110, and there's 32. So we're probably about right. Let's just go. So, when you look at Andromeda, you see more than one galaxy for this one, too. Okay. Fantasy says, I keep thinking you're talking to me because that's my name too. I'm not sure what you're referring to. The other problem with the delay of the broadcast is when I see your guys' reactions to things I'm saying, it was something I said like a minute or two ago, and, well, I don't remember what the heck I was saying, so sometimes you'll have to refresh my memory. Alright, well there you are, you big beauty. Let's turn this off for big objects. And, well, you know what, no, let's just go ahead and leave it on. Let's just leave it on low. What the heck? It's fine. In the meantime, we need to balance these colors out, and we need to get this histogram, move it back out to where it makes a little more sense. Yeah, well, thanks to the favorable angled 45-degree position of this, we're actually able to get a lot more of it than I thought we could. If it was straight sideways, or certainly straight up and down, we'd only get about half of it, but in this case... Oh, Ollie. Okay. You're both Ollies. Got it. So this, obviously, Andromeda is our closest neighbor. At only about 2.25 million light years away. It's probably the parent galaxy to the first galaxy we looked at the very beginning of the night, the Triangulum. I think the Triangulum is a satellite of this. And this is the only galaxy that can be seen naked eye in our sky. If you're in dark enough skies and you know where to look, you can definitely see the fuzzy little ball that's up there. It is the only extragalactic object that can be seen naked eye. For everything else, we gotta have telescopes and gear, because our eyes aren't sensitive enough to see this stuff without such things. So, but that's because it's our nearest neighbor. And of course these other things are galactic satellites as well, Triangulum, and then M110 up here and M32 down here. They're satellites of the Andromeda galaxy. All of them apparently are. And all the stars you see in this image are obviously in our galaxy, very much in the foreground. So if you could go to the edge of our galaxy, you'd see this without any of these stars. Yeah, it collects a lot of light. Honestly, 60 seconds is probably a bit too much for this galaxy. I would probably do better with. Yeah, the curve is only about 25% of the way in, so that's okay. If the curve gets more than about a third of the way in, it means I need to reduce the exposure. So this is doing okay, actually. Not going to really get very aggressive with the stretch, though, because the more aggressive you go, the more blown out the core gets. As Elle pointed out to us when we were doing the Iris Nebula, if something's got a bright core, but is an otherwise faint and delicate object, it's a tough balance between what you want to look at. You want to see all that beautiful wispy outer stuff, you have to stretch it and blow the core out. And if you want to see the core, you have to back way off on the stretch, which loses all of the outer stuff. So a delicate balance until they come out with cameras that have infinite full well and infinite dynamic range that doesn't saturate. We are limited by our technology, by the technology we need to see this stuff. So okay, put this up here. Andromeda. For those who know where to look in the target name window of the SharpCap. The good news about this is we don't need to spend a whole lot of time with it because it's so big and bright. Start looking for new stuff fairly soonly. I wonder if there's any others. I think we've done the Wizard. The Wizard isn't fairly big, but I think it's mostly a mission, if I remember correctly. Do they have an image of it? Yeah, they do. Yeah, see, it's red. It's a pretty nebula, but it's mostly a mission. So not really what we're set up for. We're better off with reflection. Yeah, same with Cave. The Ghost of Cassiopeia is a mixture of reflection and stuff, but I wouldn't call it a best of. So I think we'll flip over the meridian and, whoa. Well, that was interesting. My mouse stuck. We'll flip over the meridian and do some stuff over here, including M45, which has already been requested. So we'll do that too. What's this one? In the meantime, we'll take another minute or two on this, and then we'll go over. Yeah, Pac-Man is it's another emission. It's another emission nebula, not reflection. So certainly would be better with the NBZ with a dual band filter, but it depends on how dense the star field is in front of it. Actually, one of the really nice ones to do is drawing a blank. I'm drawing a blank. Not Cave, not Cone. Oh, jeez, I can't even remember. What is the name of it? Not Wizard. cave. What am I thinking of? I can't recall what the heck it is now. I was just looking at it. No, not that. We already did the iris. Not the wolf's cave. What am I thinking of? I can see it, but I can't. I don't remember. I'm not recalling the name of it in the moment. Thank you, Ollie. Cocoon. That was it. Again, Ollie saves the day, and it's 4:30 a.m. his time, so you know I wouldn't even be conscious. Cocoon nebula. Yes. This one it's a mission, but it's surrounded by a bunch of dark nebula, so it's actually very cool. So I want to hit that before we go over. And in fact, this is enough time on Andromeda. I mean, it's such a bright and beautiful object that we don't need to spend much time on it. But it's a pretty one. Let's go look at Cocoon real quick. So much good stuff. So much good stuff to see. Just hope it's not too low. It's to my northwest, and I'm kind of surrounded by buildings here, which is good because then it blocks the light from neighbors. But it also means my horizons are not exactly too low, which is also good because the lower you get, the crappier the skies are. Alright, so that's settled in there, and now we will do... Hey, Michael. Thanks for stopping in. Oh, good. What did you see tonight? Anything good? Yeah, name that tune, exactly. Not cave, not cone. I knew it was a C. I just couldn't come up with the name. Thankfully, Ollie is the most... Ollie's sharper than I am right now. Certainly. Cocoon. This one's actually very cool. Even without the narrow band, this emission nebula pops out nicely. Alright, let's see how my drink has cooled yet. Okay, we've already got a satellite crashing through, but thankfully it's way out of the way, which we won't care about. Alright, so this has got such a cool little trail of dark nebulosity leading up to it that, and there actually is some, you can see a lot of the blue, like sort of like a blue frosting around it, and that is reflection nebulosity up there. And just a very pretty nebula. So it's kind of got all three pieces of nebula there. You've got the red emission nebula, you've got some of the blue reflection nebula, and then you've got the dark areas of dark nebulae that are here that are blocking out this very dense background star field. Yeah, that works. And we'll let this go for a minute. Terrible clouds, Michael says. Managed 2 ARPs and the hidden galaxy before clouds ended my evening. Yeah, the hidden galaxy. You know, I haven't seen that in a while. That's actually not a bad one to look at. Hey, thanks for the idea. I think we'll try the hidden galaxy. Am I using a filter? Just UVIR cut. So technically broadband, we're just lopping off the edges to help with focus and star color, but other than that, pretty much broadband. Which is how I prefer to do it when the moon is not being obnoxious. When the moon is being obnoxious, then I throw the NBZ on. But the hidden galaxy, I haven't done that in a while. Let's see where that is. Is that in a good spot for me right now? Oh, you're not gonna give me the NGC number, Michael. What is the NGC number of the hidden galaxy? One of you guys will know it. Caldwell 5. Alright, Caldwell 5. Camelopardos. Mafi. Mafi 1. Which side is it on? It is on the east side, so we will have to flip, but that's okay because we were headed over there anyway. So we'll do this one. We'll finish up on the Cocoon. We'll go do the hidden, and then we'll go do M45, which I know L is waiting for. Because we'll be flipped over. I guess I can tell you a little bit about it here. The Cocoon Nebula is a reflection and emission nebula located in Cygnus. It's a cluster of 9.5 magnitude stars involved in a bright and a dark nebula. The cluster is also known as Colander 470. It's about 4,000 light years away from us. The central star that lights it formed about 100,000 years ago. Boy, that's barely an infant. It's about 12 arc minutes across, which is equivalent to a span of about 15 light years. When viewing IC546, the Cocoon, dark nebula Barnard 168, which is this dark trail here, is an inseparable part of the experience, forming a dark lane that surrounds the cluster and projects westward, forming the appearance of a trail behind the Cocoon. And it's what makes it so visible. It's not being clouded out by all these stars, because the dark nebula that surrounds it cuts the stars back, kind of like what a nebula filter does, or dual band filter does. So, in fact, we're probably getting to the point where we've seen the whole thing. Now let's zoom in and see a little bit more of the nebula itself. There's a lot of stuff going on in there. Thanks, Ollie. Yeah, it's amazing the difference. You know, my newt at f3 could not get this much reflection nebula. I didn't know there was this much here until I started looking at this with this setup. I always got the red emission part and maybe just a little tinge of blue around it, but I never got this much until I got this setup. The extra speed, and this is almost 3 times faster than my f3 newt, gets the rest of this nebulosity, which is just pretty amazing to me. So it's a pretty nice little nebula, as it turns out. It's a nice mix of things. Yeah, dual band filters like the L-Enhance, L-Extreme, etc., my NBZ, all that kind of thing, will definitely knock the reflection way down, because of course the reflection nebula is full spectrum. It's reflected starlight, which is full spectrum light. So the more of a filter you use, the more reflection nebula gets cut down, because the stars are getting cut down. So advantage of just using a UV-IR cut and having dark skies is I can let it all through now. But I don't know, maybe with the Newt and Nexus I never looked at it without an emission filter. I suppose that's possible. I may have never tried to look at it broadband, so I suppose that's possible. But I've never seen the blue reflectivity in this like I can see with this setup. Alright, one last view in situ. And then we're going to blaze over and take a look at the hidden galaxy next. So we'll have to do a radiant flip and get over there. But I think we're just going to stay over there now. Okay. Good night, Cocoon. And hello, Moffy1. It's not real far over the meridian, but it is there. Okay. Let you get in there. It's actually a nice sized galaxy. It's called the Hidden Galaxy because it's just in a fairly dense star field. And but it's and because galaxies are also full spectrum objects because they're composed of stars, you can't really use, the more of a filter you use to try and knock down the foreground stars, the more you knock down the galaxy itself. So this is the perfect way to look at it. Broadband only. Michael says I'm in Bortle 4, but 2 is a whole different universe. Yeah, I'm not quite as dark as 2. I'm more like high 2, low 3. Vegas is only 80 miles away as the crow flies. So basically the bottom 25 or 30% of my eastern sky is the light dome of Vegas, but the rest is pretty dark. And so I do okay with it. So, but I'm not real Bortle 2. I'm more like 2.5 or something is what I call myself, depending on which light pollution map you look at. And so, yeah, but still, the difference is still there. It's between 4 and 2.5, even 4 and 3. Well, is the Bortle scale like logarithmic? Maybe it's not that mathematical. But yeah, it does make a big difference. You know, with Bortle 4, you can't necessarily get away with doing broadband by itself. There we are. In all its beauty. And some nice pretty colored stars around it too. Young hot blue stars. L asks, any issues with camera tilt? I've heard the Hyperstar could be a challenge to align. By the way, the stars look good to the corners. Yes. Any issues with camera tilt? Okay, so I should say no. Not a bit. I did not find the colimation to be terribly difficult. In fact, what was recommended to me when I first got it, and I did buy it used, it was not new, and the guy who used it before me said, you know, I used this on a 50-plus-year-old, you know, C8, so the colimation was kind of wonky, and so I had to really adjust. So you may want to make sure that you zero it out before using it, and so that's what I did. And that was the advice I got on cloudy nights, was to just zero out the colimation, bring the Hyperstar all the way to against its base, and then just start from there. Because most of the time, what you find is that that's pretty darn close right at zero. And sure enough, for me it was. I had to do a little bit of an adjustment on one of the sides, and one of the 3 legs, just a little bit. But that was it. It was actually pretty darn close to being right on. Now, as I said, my C8 is it's an 8SE. It's the OTA off an 8SE, so it's a fairly new, you know, maybe a 10-year-old or so scope, give or take. So it, you know, it probably is. It's not a beat-up scope, and so it probably is in fairly good shape mechanically, and so I don't really, you know, have any issues with anything being loose or mirror flop or any of that kind of stuff. So I have never had any issues with collimating it. It was fairly simple for me. Well, okay, fairly simple. It took me 2 or 3 hours to collimate it the first time because I didn't know what I was doing. It's a little bit of trial and error, and I use a Tri-Batinov mask, which is another whole skill set. But once you learn how to do the collimation with the Tri-Bat mask, it puts up 3 sets of the triple marks, the triple, what do you want to call them? I don't even know what you would call the sparkles or whatever. It puts up 3 sets of them, and so each one is a different thing, and you use one as a reference for focus, and then you adjust the other 2 until they're about right, refocusing between each one. So it was just, I'm very used to collimating newts. I've had newts for years, and so I was just very used to that. I'd never collimated an SCT before, so it took me 2 or 3 hours to get it done just because I didn't know what I was doing. And now it's very easy. I'd be able to do it in much less time simply because I didn't know, I didn't know what I was doing then. For me, the biggest thing was, at one point, it was kind of funny because I was to do an adjustment and it would get worse, and I'd do an adjustment and it would get worse, and I'd go the other way and it would get worse, and it's no matter how I adjusted it, the collimation, which started off being halfway decent, was getting worse and worse, and I was like, I could, no matter which way I turned things, it got worse and worse and worse. I didn't know what the heck to do except go back to 0 and start again, which is what I ended up doing. And then what I realized is I was getting further and further off because I was getting mixed up as to which adjustments went with which set of 3 the Batinov lines. And so I was adjusting the wrong things with the wrong so one of the biggest things I learned was keep track of which set of adjustments go with which set of the Batinov marks on your screen, because there's 3 sets of them with the Tri-Batinov mask. And once you keep that stuff straight, it makes it much easier. I was just getting confused, and I was adjusting the wrong adjustments for the wrong sets, and it was just spiraling out of control, and I had to just start all over again. So for me, I did not find collimation difficult once I had a learning curve done, and it was not very difficult at all. It's I think it's easier to collimate than a newt, although I got pretty fast at that. It's just another skill set, and I got pretty fast at that. So most people think that's quote unquote difficult, but I don't really think it was all that difficult. So this was just a different way of collimating stuff, and I just didn't know what I was doing. So, but no, I've never had sensor tilt issues. It was not a challenge to collimate once I knew what I was doing. There's instructions. Like I said, the biggest thing for me was keeping straight which adjustments go with which set of lines, and then you're good to go. And you move it one way, the line goes up, move it the other way, the line goes down, so you figure out pretty quickly which way to go, as long as you keep track. Okay, no, this set of lines is off, and it goes with this set of 3 adjusters on the Hyperstar. And this other line is off, but it goes with this set. And you keep them straight, and then as long as you're adjusting the ones that you know are the right ones, then everything goes well. And it was pretty easy once I reset everything and started over. But yeah, basically my first advice to you is, if you get a used one, or even if you get a new one, make sure you 0 it out. Just put it all the way to 0 against the body of the Hyperstar, and just start from there, because 9 times out of 10 it's going to be pretty close like that right out of the box. So, and then you mentioned that the stars look good to the corners. Yes, number one, I have that. I use the Tri-Batinov mask to collimate it, so my collimation is pretty good. But the 183 is also only a 1-inch sensor, so it doesn't really put the collimation to too severe a test. If I had a 2600 on here, or another APS-C or bigger sensor, then you'd probably see some weird stuff going on in the corners, and I'd have to get a lot more precise with my collimation. But one of the beauties of a smaller sensor is you get to avoid a lot of those problems. So Galaxy is yellow. Oh, it's okay, Michael. It's hidden behind dust, which reddens it, makes it sort of yellowish. It would be one of the brightest galaxies in the sky. Yeah. In fact, it's pretty close. It is one of our. I think it's only like 12 million. Yeah, this says 9 million. I think 9 or 10 million. So it's 3 times farther than Andromeda, but it's still one of our local guys. It is one of the closer galaxies to us, and so let's try stretching this a little more. We got some good subs in. Whoops! Boy, I hate it when I wrong button. All right, now I have to restart. I don't know where I am now because I just totally messed that up. I like using the shift drag for the fine adjustments, and I just totally messed it all up because I accidentally pushed the control button, not the shift button. You have to use the control button for the zooming and the shift button for the fine adjustments, and if your fingers are in the wrong place on the keyboard in the dark, it can get a little dicey. Of course, I could also use the zoom on the histogram, but I just prefer to do it this way. But it is a beautiful, beautiful galaxy. Now I'll use the control to zoom in. I like keeping that blue star in there just for the contrast, but we can zoom in and see if we can catch a little more detail from this. You're welcome, Elle. No problem. Yeah, no, don't be scared off by the people who say they're hard to collimate and blah, 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 blah. People have been raving that kind of crap about reflectors, Newtonians, forever. And I love Newtonians. They are not that difficult. Collimation is just a skill set you need to learn, and then it's a piece of cake. Don't let the refractor snobs and etc. scare you off from it. And don't let them scare you off from the Hyperstar either. Starizona makes a really quality product. So don't be afraid to get in there and get one. Get in there and get your feet wet. Michael says, I've got an 18-month-old Edge HD, which I bought new and never had to collimate. Still pretty good, but I can see it's not what it was. Have been dreading it as it's something I've never done. Yeah, it's actually not that difficult. With if you're not, well, yeah, it's not that big a deal. If it's way out of collimation, then you start off with what's called the Hall of Mirrors. You basically put it on a table and stand 10 or 12 feet in front of it and look down it and make sure everything makes concentric circles. And if not, you make some adjustments to at least make sure that everything you're seeing is concentric circles when you look down the front of the scope. But that's if the collimation is way off. If your edge is still pretty good, you're not going to need to do any of that kind of stuff. I would just get a Tri-Batinov mask, and they're cheap and easy to acquire, easy to put on, a lot easier to put on without a Hyperstar on the front of the scope, but that's another story. But they're cheap and easy to use, and yeah, like I said, if you've used a Batinov mask before, then you know the Batinov mask puts up a star pattern with 3 long spikes that go out from either side of the star, and then you adjust your focus until the middle line is dead center in the trio. And with the Tri-Batinov mask, you're not seeing one of those, you're seeing 3 of those at different portions of the clock. They're about 60 degrees apart from each other. And so it's the same type of process, same exact thing. You're just needing to keep track of which set of screws on the Hyperstar or which set of screws on the secondary mirror adjustment when you collimate it with the regular setup with the secondary mirror in, which screw goes with which thing, and then you're good to go. And just keeping that straight is what's most important, and then they are not difficult. It is not difficult to collimate. Okay, blah blah blah, yakety yakking here. The Hidden Galaxy, very cool Very cool little galaxy that I didn't even know about till about 6 months ago. Somebody told me about it. Hidden galaxy. Well, I guess now we know why it's called hidden. Most people don't know about it. But it's a very cool little galaxy. It's just cluttered by a lot of stars and dust, like Michael said. Does SharpCap's Batinov Assistant help? I've never used it. I think I tried once and just got really frustrated with it. No, I just use the Batinov mask the way it's designed to be used, right on the screen. You know, center and focus on a bright star, put the mask on, make your adjustments. Bob's your uncle. I've never used the tools. I've never used the focusing tools in SharpCap. I've never found the need to. Okay, what do we say we're going to do next? I believe we said we were going to do the Pleiades for L, who wanted to do those. Okay. Now, the trick with this is getting everything, well, getting as much as I can in the field of view. And actually, that's pretty good. That's not too bad at all. Maybe just a squidge lower. So I pick a star that's, yeah, maybe that. Yeah, we'll get just a squidge lower to try and get most of it in. I will be able to get most of it. You know, I think I'm going to go even lower again. We'll just go to that one. I think that is usually the... Come on. Why are you not allowing me to pick it? You're not allowing me to select the star? This big, bright, honking star you won't let me frickin' pick? Ah, whatever. Okay, I think this is probably good enough. Yeah, this'll get most of the excitement. Okay. So, good night, Hidden Galaxy. Thank you, whoever suggested that. Was that Ollie again? One of the Ollies? Okay, 1, 2, and let's go get the Pleiades. How close are we to the meridian? Ah, not too bad at all. Okay. Alright, let's plate solve our way into the center of that. Get the exact star I wanted to get to maximize our nebulosity, hopefully. Alright, well, it says we're there, then let's go. Again, this is probably one of those objects where 60 seconds is going to be a bit much, but we can just back the stretch off if need be. But yeah, this will be one of the most, one of the biggest and brightest things we'll look at tonight, certainly. The old Pleiades, a great binocular target. If you want to just go outside and not set anything up, it's a pretty darn great binocular target. All right, 20 seconds to first sub coming in. Blown out. Alright, let's balance the colors, which are going to be obviously pretty blue heavy. And we'll take this. And we'll bring it back a little bit. Won't get too aggressive until we... Oh, thanks for being here again, Tiffany. Thanks for stopping by. Happy New Year to you. Huh. For your first asterism you ever noticed, huh? Well, oh, no, that's not what I meant to do. How cool. Sometimes I call it the micro dipper. There's the Big Dipper and there's the Little Dipper, but this one is the micro dipper. It still looks like a dipper, just really, really small. about LBN 7777 next? Okay. How about LBN 777? We'll stretch it to within an inch of its life. Vulture head. Whoa. Well, obviously we don't want to do that at that spot. We want to do it probably in this spot. So we get the whole thing. Maybe that's a little too far. Pick one of these. Vulture head. Alright. Certainly won't be as bright as Pleiades, but then again, very few things are. Yes, it's funny you should say that you're now thinking about a Hyperstar. I usually broadcast on Night Skies Network most of the time, not usually YouTube. And since I got this and have been broadcasting over there, yes, I have been accused of spending other people's money because now they are also lusting after Hyperstars for their SCTs. So yeah, when you see what these things can do, it's pretty impressive. Now understand that what I'm doing here also is stop doing that. What I'm doing here is I'm also using this broadband in fairly dark skies, so your results will probably be a bit more modest with if you're in a brighter place where you have to use, filtration and whatnot. But there's still it is a huge benefit. Even if you use filters, you're still going to see a lot more in a much briefer period of time. With a much simpler setup. You don't need guiding. You don't need, you don't need any of this long exposure stuff to pull in a lot more light. So, it's definitely, if you've already got an SCT, it's definitely a very cool thing. But in my case, it was worth it just to do the whole thing. Get the scope and the Hyperstar. I'm cheap, so I like buying everything used, so I had to wait a little while for all the pieces to fall into place. But it's totally worth it. If you want to just spend the money and go buy it, you can do that. And it's a huge benefit. I've seen lots of forum posts in the past where people say that the Hyperstar is a game changer, and like, okay, yeah, I can see how that could be, but damn, until you actually experience it, it's like, wow, it's quite the difference. And you're right, what you say, speed is king for EAA, and since I'm 100% EAA, 100% visual, 100% imaging, 100% EAA, that's definitely what I like. Definitely does good for me. It does so powerfully on the blue that the off color, the more hydrogen-ish brown stuff around the edge, which I got more at f3 than at f19. I got a lot less of this blue, but I got a lot more of the off color, the secondary color stuff at f3 than I get at f19. Yeah, see, it all just goes away if I do that, but if we try and just back down on the blue a couple of ticks. Yeah, see, we get a bit more. If we cut down on the blue, then we get a bit more of the off color. Bit more of the off color stuff. Yeah, see, we get a little bit more of this extended off color if we cut back on the blue and cut back on the stretch a bit. I guess actually just cut back on the blue. Try and bring that forward again so it's stretched enough for you guys to see it. It's very interesting with the broadcast. It's very lossy. The broadcast, the compression algorithms that YouTube and Night Skies Network, etc. use are pretty darn lossy. So I have to monitor my own broadcast on a second computer, because I have to see what you guys see, because what I see on the control computer is significantly brighter and different. I actually have to, on my control computer, I have to adjust the histogram until it's pretty noisy and almost blown out for it to look right for the broadcast. So it's a bit of a balancing act, because it doesn't look very good on my screen here on the control computer, but the second computer has it looking pretty good. There is definitely a significant difference, but you can see by cutting back on the blue we do get some more of that secondary color, but I really have to play games to do it. With the newt at f3, I got naturally somehow more of the off color stuff. Still got a decent amount of the blue, but not as much of the off color. So just interesting stuff. Michael says, a friend just did an AP version of M45 background is all IFN. Wondering how long it would take to show up on this setup. He had 5 hours of integration. Yeah, well, you could calculate it based on his focal ratio. You know, if he was a typical refractor user, an f7 refractor with, you know, maybe a 0.8 reducer or something, so he was like at f5 or f5.5, then, you know, he'd probably be 6 or 8 times slower. I could probably do it like in 1 hour or less, depending on how speedy his setup was. I actually kind of like it with the blue turned down a bit. Gives it a bit more. See a little bit more of that off color. And you can see some of the surrounding stuff starting to come in. Cuts the glare down. Yeah, Bortle 2 versus Bortle 4. So this friend is also in Bortle 4. Yeah, the skies do make a difference. I've got it stretched to an extreme at this point. It's probably a little bit noisy, but it lets you see the outer nebulosity a bit better. That's a bit cleaner looking, but still, it's pretty nice. Okay, LBN 777, Ollie says. Alright, let's go see we can see over there. That let it get this last sub in, and then we'll head over. The Pleiades. Alright, well, let's go look at next target. Let's go look at the Vulture or Eaglehead Nebula. That wasn't much of a slew, was it? In fact, I don't think we're even going to bother plate solving. That probably is going to be pretty much right on. Thanks, Sel. Glad you stopped by. Appreciate your time. Glad you enjoyed yourself. Maybe I'll see you next time. Okay. Wonder. See if. No. I was going to see if Vulture nebula. No, that doesn't seem to have anything on it. This one will definitely be a much more subtle one. All right, let's get our colors mixed right here. Yeah, this one's definitely going to be more subtle, no doubt. This one's definitely going to be more subtle. Yeah, really going to have to stretch the heck out of this one. Yep. Again, I'm waiting for the broadcast to catch up so I can see how bright or dim this thing is. Yeah, it's going to be an interesting one to see. Well, we'll have to give it some time. Yeah, good one, Michael. Witch Head is definitely a nice faint one. So I guess that gives me a good idea. And we'll go look at that one. Witch Head. That's definitely a faint one, too. We'll do another couple on this. I don't know if we're going to get a whole lot more out of it. But it's definitely a very faint one. Witch Head, I think, is actually brighter than this. But that's probably just because of the Witch Head is right next to Rigel, which is a massive star heating it all, lighting it all up. So this guy doesn't have, doesn't really have much of. Well, I guess Pleiades would be the, well, maybe, depending on how far away this is. I wonder if, let's see if Stellarium, Vulture Head. What does it say? Does it have a distance? It does not. It does not have a distance. Oh well. Oh yes, Witch Head is massive, but I can at least do the brightest part, the top of it, and you know, see how we do with just doing the top of it. Alright, we'll take this 10th one and then we'll head off. Parts unknown. Yeah, Orion's pretty well up there. Eaglehead. Okay. Well, Witch Head is getting up there, isn't it? What we got here? Reflection, yeah, okay. Alright, let's just stick with the theme of Northern Triffid. You know, have I ever done Northern Triffid? Okay, you're distracting me again, Ollie. Jeez, with all these great suggestions. How do you see 1579? 9. Northern Triffid. Have I done Northern Triffid? That means headed. Yeah, it's hydrogen. It's a lot of reflection, but where are we? Oh, I'm over here. Yeah, we're pretty close, huh? Okay. Northern Triffid has been requested. We'll go do it. Yes, you should be sorry, Ollie, with all these great suggestions. Keep distracting me off the stuff I was gonna do, and they're all good suggestions! So how can I say no? Okay. Again, I don't think I'm going to bother plate solve, because I think it's such a short slew. We should be pretty good. try the witch head later. Maybe I'll just alternate. I'll do dim one, then a bright one, then a dim one, then a bright one. So maybe we'll do Casper after this, I think. Casper is another one that's this setup really has surprised me on. I'm amazed at how much more of it I can see with this setup than I could at F3. I mean, I've never seen Casper like I can see with this thing. So, anyway, I'll show you guys what I mean next. But first, we'll take a look at the northern triffid. There it is. Histogram nearly perfectly adjusted already for it. Well, I guess we'll get it a little more than that. Obviously, we have a nice mixture of dark nebula in here as well, with all these dark flowing portions. So we get to do some dark nebula as well as the bright stuff, and there's certainly reflection in here. You can see the blue around a couple of these stars. So we've definitely got some reflection action going on. I'll let this get a couple of subs and probably right up here when it's northern triffid. Definitely not as much reflection in this one as there is in the southern triffid, but I can see why with the dark dust lanes going through here, the dark nebula dissecting it a bit, why they think it looks like the triffid. Good night, Michael. Thanks for stopping by. Appreciate you being here. See you next time. Have a great night. there's 10 minutes on the northern triffid. Zoom in a little bit more. Yeah, I can see a little bit of a resemblance, I guess. Definitely not as much reflection nebula with this one as there is with the regular one, but still, got some interesting stuff going on there. Definitely fuzzy and hazy around these stars. So, pretty cool. Alright, let's head to Casper. Not Wyoming, it's too windy. Casper the Friendly Ghost. There's our scope. There you are. Gonna land right on in there. Okay, and we will take our plate solve. Should be pretty close, and it is. Let that reposition. Doink. And go. Okay, well, it said it moved to 0.81, but it doesn't seem to do nothing there. Okay. Back this off a bit. Hey, Mike. Thanks for stopping by. We've seen a few cool objects so far, and now we're going to look at Casper. Casper the Friendly Little Ghost. And then, given that it is still almost the season, we'll look at Christmas Tree after this one, I think. Casper the Friendly Ghost. Okay, something like that, maybe like that. And you can come in here and do maybe that. Ooh, and we got yes, so now we're getting into this southern sky, sort of. Hopefully this is going down and not up. But it'll be what it'll be. And out here we get some of the red from Barnard's Loop that shows up. Some of this stuff from Barnard's Loop will show up in here. Oh, looks like that stupid satellite is going to go right through the dang image. And obviously it is a geostationary, doing about 15 degrees every sub. just can't look at it. Let it go ruin elsewhere. Yeah, Mike, it's one of the more ignored Messier objects, M78, Casper, because for most folks it doesn't look like much. I mean, even with my imaging newt with the Nexus at f3, I was not able to pick up nearly as much with that as I can with this. So, you know, when you've got the right gear on it, there's actually a lot more to this than most people can see. I mean, I was at f3 and couldn't see half this. So, for some reason, lots more speed just picks up lots more stuff, or lots more time, which as an EAAer, I don't spend too much time. So, it's I've never seen this like this before. I mean, since I've gotten this new rig at f1.9, I'm seeing a whole lot more of things than I ever saw before. I never knew a lot of this stuff was here with Casper. You know, I could see the little, here with the little two eyes, and then I could see this second spot here, but I never really saw any of this connecting stuff, and really not much of this either. And the dark nebula never really stood out as starkly as it does here. I think I would always got a little bit of the Barnard's loop, but I never really saw nearly as much as I get with this. So there's just a lot more here than and I think most people ever realized with the EAA setups they have. Now the AP guys, they probably, you know, they probably know all about this, but you know, for me, this is pretty new territory. I mean, even at F3, I wasn't getting this, which is just crazy. Good night, Michael. Thanks for stopping in, and you know, we can keep chatting on cloudy nights as well. Thanks for stopping in, and I will see you next time. Yeah, they are. The colors are really nice with this, and for some reason they were just more muted with the 676. I don't know why, but I was just never able to get this amount of color. Now, admittedly, I've only put about 6 hours of session time into the 676, so I don't know. Maybe I should do more with it, but this I was just not able to get as much out of the 676 as I can with the 1A3, which is just producing all kinds of colors. I mean, maybe it's just the lower full well, because you know the full well, the 183 is about 50% bigger than the 676. So I don't know, but this does really produce nice color. Let's try popping this over a little, giving this a little bit more. Yeah, the TV probably sees some more noise. I've got it stretched pretty hard to get all this color, and I like the faint outer stuff, so the price of doing that is it gets a little noisy. But yeah, I mean, at F3, I never realized any of this marbling was here. Any of these dark lanes and dark nebulae, I never really knew that any of this stuff was here before. And down here, there's even dark nebulae with stuff trying to poke through. Just never knew it was here. In fact, I mean, I could always see the two eyes. I could always see Casper's two eyes before. You know, I mean, these two little eyes, I could always see them before. Now I can't, and now it's like I'm getting in so much light that the eyes are obscured. I mean, this is probably the best I got before. Probably something like this is about the best I got at F3. So it's quite the difference at F19. Quite the difference. But again, I'm stretching it very aggressively, so so the downside is there's going to be a little more noise. And yeah, it's quick stack is noisier, so I'm going to give this a couple extra minutes because it really deserves it. But I have never seen Casper like this until I started looking at it through this setup. I had no idea all this stuff was here. At least not through my own images. I guess you go look at the Stellarium image, it kind of shows that, and a bit more color saturation too. It shows that it's all connected in a much larger field. And all this is all connected. Mine is on the bottom because mine is flipped. Really what I need to do is doink that. That's kind of what I'm seeing here. A little bit rotated because the Hyperstar flips everything. But well, we'll finish up this one last sub, and yeah, I agree, Star Traveler. The Hyperstar definitely gets you some stuff you don't see with anything else. Okay. No. But where's my? We'll go get the Christmas tree. Since it still is the season. Thank you, Casper, once again, showing very nicely. Now, I'm going to want to move this. I know already I'm going to want to move it. In fact, I'm just going to go with a 15-second sub and stretch the heck out of it. Okay, it's up here. Yeah, so I want this to be over there. So we'll do this, and we'll do about like that. Too far. Please plate solve again. Okay. think we're going to be pretty close here. Turn you off. And we'll reset you. We'll wait for the first sub to come in on the Christmas tree. Yep, so I think what we're going to do is we're going to do the Christmas tree right now, and then we're going to do the Alnitak region with the horse head and whatnot, and then call it a night. Been out almost 3 hours so far. Yeah, that's pretty good. I wish it was lower, but what are you going to do? I want it lower by about that much. Okay. So we're going to restart this. Restart it. Restart it. And that should have it about right. This should be right about where I want it. Yeah, that's showing a lot more of the lower part. Good. Okay. No, Mike, I don't. With the 183, you've got to keep a current darks library anyway. So basically every 6 months I take a new set of master darks for it. And so in the fall I take my winter dark set at -10. And then for the summertime in the spring I'll take the summer set late in the spring for +10 degrees C. And that works out about right. In the summertime, when I'm out here, it'll often be over 40 C when I start, first part of the night. So trying to make the camera do more than 30 degrees C is asking for it. So basically in the warm months of the year I do +10, and in the cold months I do -10. I doubt very much that the camera could do -10 in my summertime temperatures here. That would be demanding like a 50+ degree C temperature drop, which I doubt it could do. Yeah, well, I gotta stretch it more. Stretch it more. So we can see some of the bottom part of this. Where are you located, Mike? Ah, San Diego, okay. Well, then you know, down here in the southwest, we get some hot desert stuff. So, I don't know, maybe you travel east in the summer to do some astronomy, get away from the marine layer. But it's pretty warm here in the summer. You know, we'll cross 50 degrees C on our hottest days up here. Down there on the I-8 and I-10 corridors, you get even warmer, so. +10 C on the cameras is about as good as I can hope for. Oh, okay. Anza Borrego, yeah, I have a friend who shoots down there a lot. He's in Temecula, and he goes to Anza. He drives out to Anza and all over the place down there. Anza's a beautiful place. Looks like we've got another satellite coming through here. Right in here. It's pretty faint though, so I think I'm just going to ignore it. But this is a pretty cool mixture of emission and reflection and dark nebula again. Pockets of the dark nebula all over the place, even some Bach globules looks like down here maybe. And lots of red emission nebula. Definitely some fuzzy blue and white reflection nebula. Good night, Ollie. Thank you for coming on tonight / this morning and having some great ideas. I really like the that polar ring nebula, NGC 660. That was pretty cool. I really liked that a lot, and the eagle head was pretty nice too. So thank you again for being here and for your suggestions. And I'll see you next time, maybe. Okay, well there's time on the Cone Nebula and the Christmas Tree Nebula, and the Christmas Tree cluster here. So that's a pretty one. Another one I've never seen with nearly so much detail before I got this set up. Really fills in a lot with the extra speed. Good evening, Desert Sky. We're just finishing up on the Christmas tree here and going to head for the Alnitak region as a finish up, and then I'm done for the night. Been on a little over 3 hours now, so starting to get a little cool. I've collected enough satellite trails through here too. Alright, let's pop over to Alnitak. Flip this back from... No, that's not what I'm trying to do. Let's get the lump star in there. Focusing on the lump star gets me right about perfect. Okay, good night, Christmas tree. Let's go ahead and go to Alnitak. And we'll get the flame and horsehead. There's the flame and the horsey will be in there. Because again we need to flip it. Yeah, so it should be in there. Lump star up there. I think actually I want to move it up a little bit. No, not you. You. Alright, plate solve again. Yep, there you go. Let's move it up. Yes, I do want to move that. That's better. That'll get me more. Maybe even. Okay, I think that's good. I think that'll be good enough. Let's go ahead and get started. Grab you, move you out a little bit. Alright, and we'll get on the all-attack region here, and we get a little horsey head and a little flame nebula. We did Casper just a little bit ago. And we'll save the rest for another night. You know, I did 3.5 hours on Tuesday night. I said, no, I'm not going to be out there this long tonight. Sure enough, got excited. Had a number of interesting objects recommended by you observers, and yeah, it turned into a great night. Oh, look at that. Perfect. We've got a geostationary satellite tracking right through. Go figure. Tracking right on through. Incroyable. Actually not terribly unbelievable at all. In this part of the sky, this part of the sky is lousy with them. Can't stand it. Get rid of it. There, it'll be more out of the way. looks like we've got another satellite coming up from below. Right here. Yep, it's going to go right through flame. Man, these satellites are just terrible. And a third satellite. Boy, this is just really bad. Thanks, Daryl. Thanks for joining again. I'll see you soon. Appreciate your time. Have a great new year. Mike, no, I don't. In fact, I don't even save any of these images. I don't even save them as I'm going. I really am sort of an EAA guy. I just do things live, and unless there's some unusual circumstances, I don't really even save the images. So every now and again I'll post something to the NSN group, but no, I actually don't. I don't post-process anything, and I don't usually even save any images. I just like doing the live stuff pretty much. So I'll do one more sub here, especially since we've got another satellite about to bomb through. I think this will be my last sub on this, and then I will call it a night. In fact, I can see the clouds to my southwest starting to move in. It is supposed to get cloudy later this evening, so the timing is about perfect for me to bail out anyway. So I will thank you all for being here. Happy New Year again to everybody. Appreciate your time for watching, especially if you've got this far into the broadcast or the video if you're watching this afterwards. And I will see you next time. Thank you again very much for being here.